Welcome. We are going to talk about the astronomy you are going to do with your telescope that you are going to build. So, Mr. Bharat sir told me to speak to you after your lunch. So, I have to keep you awake for 1 more hour. So, if you want to sleep, you can sleep, but don't snore. Don't disturb others. So to keep you awake, I have to do something. So, I need a volunteer who can speak loudly. So he is throwing you under the bus. So come, any one of you come here, sit in front. Yeah, come. So, because you are going to do astronomy with your telescope and you want to become astronomers, I assume, so you can change. But for now, I assume that you all want to become astronomers. So two things going to happen. So when I am going through the slide, I will say that whenever I say observation is good or seeing is good, but whenever I say but, my good friend, what's your name? Pragnesh. Pragnesh will Thavnesh. Thavnesh will make sure that everybody will, in their loud voice, will say, because I want to be an astronomer. Whenever use the word but. Okay. First 2 times you're going to get it wrong, then I will guide you. Okay. Okay. So you have decided to build a telescope. It is nice, and Bharat sir will going to teach you really well. And the Birla Institute, I have to thank Young Innovators for asking me to speak here. And I have to thank Birla Institute, Dr. Sujata, and also RRI for arranging this and giving place for all you students to make your own telescopes. So why did Bharat ask me to talk about this? So I have to tell about something where I come from. I come from an institution called Association of Bangalore Amateur Astronomers. So what is this amateur astronomer mean? So, amateur means what? Tell.
So someone who is new to something.
No. Don't worry, I will see immediately say no.
Sir, between beginner and intermediate.
No. There is the same answer. Yeah, I know. Movies have ruined the name amateur, but that's not it. Amateur is something which you do it by heart without getting any financial aid. So you can Google it, and I'm sure already some of you would have already started Googling it. Amateur means something doing by heart because we love it. We don't take money for it. So it comes from a French word. So do not think that whenever people say it's amateurish work, that's a corrupted thing. Amateur means by heart. So what we do, we take astronomy very seriously, and we are from 1976, that means previous century. So we are here, and we have been doing astronomy for almost 50 years now. We make telescopes, we have discussions, we go to colleges and schools and teach them astronomy. All these things have been happening from many 50 years. So the quality of telescope what you make here is the same what you want to buy. Sometimes it is better because you are going to do it yourself. So we have been doing this from, let's say, black and white era. This is 1985. Kids like you grinding and polishing. Maybe now they are teachers. We do have discussions, and youngsters are given opportunity to talk about astronomy. Don't worry, he is not bored, but just is happen to look up. So we go to colleges, schools, and teach them astronomy. Every week, every Sunday we do this. So from 50 years we are doing this. So amateur means we do it by heart. All of us have different jobs. Some are doctors, some are scientists, some are teachers, all the things. So they come here on Sundays to explore astronomy and learn about it. So we shall start about why this talk and what you have to know before all the things. This everybody would be familiar with. Find the difference. Already few of you started finding some difference.
Sir, in the first image there's one cloud.
So,
Sir, the orange color kind of thing is missing.
where the cloud came from? So, what are you doing now? Tell me, what are you doing now? Exactly. Both. What did you see? If I just show you the one image, you look at the image. What you did, you started looking deeper. That means what? You are observing. So astronomers do observe objects. They are not just looking. Looking is different. I can show you moon, you can look at the moon. Looking at the moon and observing the moon are totally different things. Looking at sun and observing the sun is totally different. Looking at Jupiter and observing Jupiter is totally different thing. So since you have a telescope, you want to become an astronomer, so you should learn the art of and science of observing. This is color, good. Both are totally different things. Anything now, if you look at it, any object, start observing it. Give more attention to it. Know what should be there and what not should be there. So I will come to that later. This you will remember in the last slide. This slide will make more sense when we go through the slides. This is a black and white, and here it becomes much more difficult to spot the difference, isn't it?
Sir, the bush is missing. The house is missing. There's a car, there's a house.
Uh, Last page are silent. Silence, 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 silence.
Okay, listen.
One thing is, I'm sure that good, you are good observers, and Bharat had made a right choice of making and helping make a telescope because you are observing and you are keen in observing. Otherwise, I have shown the slide to many others, so they just dead silent. So here I have to make you silent. So that means that good that you are going to build a telescope and use it. So let's start with the nearest object and also most brightest object. I will not talk about how to use a telescope. That Bharat sir will tell you and Dr. Sujata and others will tell you. My job is what you're going to use it and do it with your telescope. What you're going to build, not something which is observatory, not being something very big. Okay. So let's start with the most obvious. So most neglected of all objects among amateur astronomers and professionals, those who want to look at it. So if you every day you look at the moon, isn't it? You don't look at it moon?
Welcome to my world.
One is correct. The idea is that it is next door neighbor. It is there, visible. It is bright. Even with thin clouds, you can see the moon, isn't it? So it doesn't need a thick. But with a thin moon, thin clouds, you cannot see any other object, stars or anything. But moon is visible. So we shall start with the moon. First thing you have to learn with your telescope is pointing. It appears easy, but believe me, pointing a telescope requires lot of patience and learning. So learn with the biggest object and brightest, and then go to fainter objects. Don't jump. You want to see Pluto with your telescope, you cannot see Pluto. So I'm going to tell it again and again. So there are certain limitations to your telescope, but lot of advantages which we're going to explore today. And we shall start with this. Learn to aim that moon. So all the friends from Young Innovators will show you how to aim it. Then also show you learn how difficult it is to aim, and you will respect astronomers more. So this is the thing. I'm sure you will know the answer. Any features you know, very famous features? Craters, but name the craters. Any one crater?
Sir, hell and yes, sir, it's a
Oh, okay. Suddenly you say hell. What the hell? Okay. You have to learn a lot of things. These are called, yeah, louder, louder. Mare, yes. These are the oceans. What they thought were oceans, were flat lands, the lava has flown it. And these are the craters. This is the brightest and most easy to identify. It's called Tycho. So you know who the scientist Tycho was. So each crater has its own names and it's named after scientists. And these are brightest, even with binoculars is good, with telescope even better. So you have to learn a lot of it. So you have to learn about the craters, types of craters, the oceans, and there are valleys and mountains, all these things which are visible through your telescope. So this is the crater I was showing. This one, this one will become like this with a telescope, and with a very big telescope, it will be like this. So craters keep changing in appearance as you magnify it. So you have to understand what is magnification. And also, never observe moon during full moon days. Not because your eye is going to ruin, nothing will happen, but there will be no shadows. Without shadows, you cannot fully appreciate the shape and size of the craters. So, I have not used it yet, yes. So, since it's looking is good, but I want louder. See, louder you do it, faster you do it, you can get rid of me faster. So, the louder you say you want to be, see, still lunch is still going inside the stomach, yeah. So never observe the moon. You can look at the moon on full moon days, but if you want to observe, it should be half moon or below that. So maybe just few days after new moon or few days before new moon. So never on full moon. Your eyes will not get ruined, but you cannot study anything. So people wait for it. So you have to get used to it. There's a lot of learning. There are a lot of maps are around, but you have to get used to the surface of the moon. If you don't know the surface of moon, if something new crater appears here, you will miss it. Somebody will take credit for it, somebody will discover it because you didn't know whether there was supposed to be a crater here or not. So observe it regularly, use your telescope, and anyway for moon, you don't need to get out of city. From your school or from your house, you can observe the full moon regularly. So do that. Observe the mountains, observe the valleys. So you can see now you can see even the small mountain has a huge shadow. If the shadows are not there, you will not be able to recognize the full potential of the mountain. And what astronomers do and what you're going to do for your project is using this shadow length, can you measure the height of this mountain? That is what you have to do. You can have a telescope and look for it for some time. Show it to your friend for some time. But doing science, slowly you have to understand why this shadow is casting because sun is from this side. And using the size of the shadow and angle of the sun, can you make out how big it is? That's what astronomers are doing. Till now, even now they do it. They depend on the shadow.
Is it accurate?
It is accurate.
Sir, but then I don't know the scale that if I have this photo
Yeah.
on my paper, so
Yeah.
I don't know how much, like what are the proportions?
When you are taking normal photo, you will not worry about all these things. When you are taking science photo, you have to give each pixel how much area the sky covers. So how much the field of view. So that my friends will teach you about field of view. Every photo will be given with accurate field of view. So that means if this is in centimeters, intermeters per square centimeter occupies 100 kilometers. Per pixel, it may 100 kilometers. So if you know that, you can easily do this may be 100 or 200 pixels and you know the sun angle. So you know 100 pixels means how many kilometers. So you have done all those homework and a lot of homework are there. You can do that. So now even it's done accurately, but to get it more and more accurate. So this is a plateau. It's also visible with your telescope. Very flat land, 100 kilometers in diameter. So if it was not there, you would not seen this. This is the shape of this rim, isn't it? So if the light was not there, the shadow was not there, you would have missed all these beautiful contours of the rain. So again, measure the rain shadow. Measure the shadow from here to here. You will know the sun angle. Calculate the size of height of this rim and also calculate the diameter of this. It is done very accurately. How accuracy depends on how much attention you give it in your maths class, how much attention you give it in trigonometry class. So you're going to learn all those things, geometry. To become an astronomer, this is good. You observe. For being an amateur astronomer, you don't need anything, but you want to be a professional astronomer, you have to give a lot of attention to physics and mathematics, and you have to learn a lot. You have to spend a lot of time. But these things help. These things are like homework. These things are you are playing and also learning. So this will help you a lot. So this is really beautifully visible with your telescope. Try it out. Maybe after a few days when the sky is clear, try it out. So these are the phases you will learn. Don't tell me you know. This is just to show that these are the times when you observe the moon. So you do not do anything observing moon at these phases because shadows are not there, all burnt out. So all these phases you take care from gibbous to crescent. Observe the moon, study the moon. And there are certain things, terminologies you will have to learn. The line that divides day and night of any object is called terminator. So this line you have to follow. This line you have to follow on moon. You have to follow on Venus, on Mercury, on sometimes on Mars also. So this terminator line is something which divides and gives you what phase it is in, how much you can see. So, but before all these things, enjoy and start studying the shadows. So, studying and measuring the shadows. What else can you do with your telescope? So, one thing is that you know moon's orbit is very elliptical. So, it goes far off and comes very close. This is what happens. Obviously, this is bigger or this is bigger? This one? No. Still awake. This you have to observe and measure with your telescope, which is possible. All the things I'm going to show today is from the telescope you are going to build. So this you have to measure it. Field of view, there is a method to determine the field of view. So you allow the moon to drift along your eyepiece, then do calculation, you will give exact field of view. Using that field of view and time it took, you can measure how big it is. Normally moon will be 0.5 degrees in the sky. You have divided the sky into 360 degrees. From horizon to horizon, it is 180 degrees. In that, it is just occupies 0.5 degree. That means 1800 arc seconds. Remember this. Remember these numbers because if you think that you're going to see something very big through your eyepiece, wait for it. So how do you do this? Measurement and patience. Don't tell me on a super moon, you don't come and tell me that, sir, I saw a moon, it was bigger. You cannot make it out with your naked eye. Even with experienced people, with naked eye, without measuring, you cannot just estimate it is bigger. So you should start with what? Qualitative analysis. You have to do homework and prove to yourself this is bigger. So that means measure the field of your eyepiece and also measure the moon again and again. Every month it has. Every month it goes away. Every month it comes closer. Every month goes away. So you have a lot of time. Observe it and prove to yourself this is bigger and this is smaller by measuring, not by looking. So if I show you only one photo, you can say it was bigger or it is smaller, isn't it? We don't know whether it is bigger, it should be bigger. How do you know? Measure it. Either take photograph. Even now you can take photograph with your cell phone and measure the pixels. Again, I promote very much mobile photography. I promote it very well. So use your mobile phones, take photos, measure it in pixels. So do quality work is the thing. So no estimation, Do not go by hunches. So science doesn't do that. You have to do it again, and if you get it bigger also, you have to do it at least 5 times. Take an average, then decide. So that is how science works. Requires a lot of patience. Since you want to be astronomers, you have to do it. One more thing with your telescope is this thing where moon actually, when it changes because of the orbit, you can see that it's wobbling. You can actually see it wobbling. If you observe this crater, come, see this, it goes up and comes on, it comes like this. So this can be seen with your telescope. That means observed over the days, you can take a point here or any of the craters, see that how it appears on your eyepiece or your photograph. Keep doing it for 1 month, it happens every month. It is the rotation, it happens every month. So this you have to do it for 30 days. Then you will get the idea that moon wobbles. Next astronomy question will be why it wobbles. Think about the orbits, discuss about the orbits, then ask your teachers to explain about it. Then they will explain. Now you are an astronomer, thinking why it is happening. Otherwise, you will be seeing and enjoying. This is a nice photo. This you can do it and put it, and people will enjoy it. But understanding the reason behind it is what we are looking for. Because what are you trying to become? If the voice is low, I will take 1 more hour. So you are stuck with me. So if your voice is higher, I will finish it faster. So decide. Okay, this is a small thing where this will come to that later. Did you see what's happening? This star just emerged and went back. So I will come to this later. So after moon, what can you do with your telescope? So you're not yet going to the stars, but because you are not yet ready to aim at stars. So we'll go step by step. Now we are moon. After moon, come to the brightest planet, Venus. So who said Jupiter? Okay. Venus is the brightest, nothing outshines it. Jupiter is the biggest. What is this? Mercury. So with your telescope, you are not going to see this. That means you are not going to see the craters, you are not going to see the phases, cloud patterns. But what are you going to see? You are going to see beautiful phase of the Venus and Mercury. Why the phases? Because it's inside our orbit. All these astronomy topics I will not talk about. I am here to tell you what you're going to do with your telescope. You're going to observe Venus and Mercury. Nowadays, nobody can forget if you go in the evening sky, it's the brightest star in the sky. Even moon cannot match the brilliance of Venus. So you can, one star, which is not a star, one object which is easy to identify. You don't need any apps, you don't need any maps. So this is Venus, and now this is greatest elongation. That means it's the separation between Sun and Venus is extremely high. Extremely high means just 45 degrees. From horizon, it is just 45 degrees up. So why to calculate? We will come to that later, not now. So here, evening sky, Venus, easy to observe. From moon, we are going to see Venus. And Venus, as with the moon, has phases. So now if you go out after today's session, if tomorrow's session, if the telescope is ready and the skies are clear, ask Bharat to point to the Venus and you will see half phase. You will only see the half Venus and slowly it will move towards crescent. However, it's a fantastic thing. Lights, or it's bright. I think lights back off. Switch off lights. Agata. E lights are if not, okay. So this is what you are going to see with your telescope. So I'm not kidding, I'm not hyping you up, but this is what we see every day. And yesterday also we saw it, it was here. So this is appearing good. So tomorrow when you finish your telescope, first thing you have to point out is Venus and enjoy the brilliance, and it will be this phase. So as you continue to observe for next couple of months, slowly it will go towards like this. So what are you observing here? What is the changes that's happening here? Hmm? Louder. Hmm. One is it is becoming bigger. You can talk because I cannot see you, so lifting hand will not work. So shout it out.
Like Venus is greatest elongation photo is below the date was 10/1/2025,
Yeah.
but it was like a full. But here you told yesterday it was half.
This,
Yeah,
it's not a full. It's like a star. It appears like a diamond in the sky. So with a naked eye, you cannot make out anything. This is with naked eye, it appears as a star and it has a full. Our eyes are not big enough. The resolution will come later. So it appears a star. It's just to represent a star. Once you see through the telescope, you'll start seeing all these phases. Without telescope, you cannot see. You need a telescope. So with your telescope, you can see this. What will happen from now on, it slowly starts becoming bigger, and at this time, it will be the brightest in the telescope. You remember this moon at its crescent phase, it's the dimmest, isn't it? Full moon, it is the brightest. Venus, full Venus is dimmest, and the crescent is the one which is the brightest. So think about it, why it is brightest during crescent phase when moon is dimmer. One is it is becoming bigger, and also a lot of other things. I will give you a clue, you can go. It's albedo. Yes, yes. So the surface area, you have to learn to calculate the surface area of this crescent. In geometry, they will teach you all these things. Learn about this, and then you can predict how bright it will be. People have predicted and they have been calculated. Just before it is next to sun, 36 1 month before its conjunction, that is next to sun, it will be the brightest. So in February, it will be the brightest. February end. So it's a good time you have made your telescope. So you can follow Venus and its changes from here to all the way here. And it's very easy. You don't need any filters. You don't need to go out of the city. Just stay at home or in school, in the evening sky, observe and enjoy. So this is the thing. And again, measure the field of view with the photographs or with the drift method. Do those things. What planet is this? Mars. How do you know it's Mars?
sir, did you say polar ice caps and the red color? Yes, sir.
Here, sorry. So I don't think who says it's red. Who sees it as red?
No, sir, not naked eye.
Here.
It depends on the lens which we see.
So if we change the lens, it will become blue color or orange color? No. It depends the color. That's why I made you sit in the front so that you can use mic. So if I shown you this, you will say Mars. You will show me this is Mars because you are used to seeing the photographs, isn't it? You are now say that it is red, that's why it is Mars. What if I showed you only this area? Will you be able to recognize it? No. So that's what astronomers have to do. You have to get used to the surface of Mars. So I am telling you again and again, surface of Venus, surface of Moon and surface of Mars. Actually, you are doing what? You are not doing astronomy. What are you doing? What science is that measuring all these things? Who said cosmology? Don't worry, it is fun. What science which measures the mountain, the soil? Yeah. So you are doing geology here. Still you are not doing astronomy, you are not actually doing geology. You are measuring the types, measuring the angles, measuring the contents, the features, all these things. So it's, what are you studying? Geology. So you have to give more attention to geology class in the school and learn about it. Now with your telescope, yes, with your telescope you can see all these markings. This is called Citrus Major. You can see this Grand Canyon. You can see ice cap. Thankfully, it is closest to Earth in from 2 days from now. So it will be closest, and then it will go around, and it takes 2 years to come back. So you have again somehow the planets are aligning for your telescope making. So you have made it in the correct timing. So you are going to see Mars at its biggest. So this is actual even smaller size what you're going to look through your eyepiece. Okay, you are not going to look. It's not going to look like this. It's going to look like something like this, even smaller. But you can make out all the gray areas and north ice cap. Yesterday we saw it through 6-inch and 5-inch. It was visible. So in next few days or a couple of weeks, you can see all those things, and this is a good time. Make use of it, observe it, and get used to the surface of Mars. Get used to the composition of Mars. So this is what you're going to see, all these things, and then calculate all these things. Remember this number. 96 million is the closest what is going to appear, and arc seconds, which is 14.6 arc second. Moon is how much? So how small you want to see Mars in your eyepiece. So try to do the maths about it, try to follow the maths, try to understand. Again, measure. Astronomy means lot of things is measure, measure, measure. Measure the size of it, measure the angle of it, measure the brightness of it, measure the color of it, all these things. Yeah. This does justification with all size of telescopes. So even with your telescope, you have a good telescope. So with your telescope, you can see all the bands, you can see the red spot. It needs some training, but you will get used to all these nice things, all the waves, everything. From the city you can see it. So start doing astronomy with it. Understand what is Jupiter, what are the bands made of, and how fast it rotates. You can actually measure. So you have been told it rotates how fast? So you have been told, but being a science student, you have to measure it. So you measure the red spot moving from here to here, see how fast it goes, then calculate the full rotation. All these things you have to do it, and it's very easy because if you say it's 9 and 10 hours, that means you can actually measure from here to here in a night and come to the conclusion how big the how fast the Jupiter rotates.
Sir, and it comes really close to Earth every 13.6 months.
Correct. How do you know that?
Sir, I searched about it.
Exactly. Now, since you have a telescope, you have to measure the size of Jupiter for 13 months, then measure the size, how it bigger becomes. So biggest will be the closest, isn't it? So homework is, since you search for it, so now the homework is 13 months long. So you have to measure it 13 months. Okay? So don't worry, it will come to you. This is the thing, and get used to the bands. All the dark areas are called bands, and light areas are called zone. So this is mainly made of Jupiter, methane. Forget about all those things. Get used to the surface and get used to the name of the bands and the direction you are looking at. So red spot is in the southern hemisphere of the Jupiter. So if any photo you show, you should be tell it is the southern part, this is the northern part. Because anybody can appreciate Jupiter, it's a nice photo. But since you want to become, you're going to 3 hours long now. So it's going to be stretching, it's going to stretch. So I will not let you sleep or let you leave. So I'll put you in liquid oxygen. So southern hemisphere. So try to divide the Jupiter and see which is the south, which is north, what should be there, what not should be there. The thing is, I'm telling you again, as astronomers, you should know your object. Search for it. Because if you don't know what it was made of, what is the difference now? Okay. Now looking and observing. You said yes. Shades, yeah, little bit shade changing, but I want a concrete answer. Observe. No.
Sir, the band size is changing.
No.
Like the bands near the red spot, they're comparatively different in the first image than the third image.
There's not dimmer, there's no band here, you just band here.
Yes, sir.
Exactly. If you don't know the bands, you wouldn't have recognized, isn't it? Actually, this has happened. What is the date here?
May 13, 2010.
9 and 10. 2009 and 2010. If you are a regular observer, you will recognize that bands do disappear and come back. This is the observation, and astronomers need you people because they don't have enough telescopes. They need amateur astronomers and students like you to keep observing and inform them if there is any changes. Around the world, students are regularly looking at moon and taking logs and reporting if they see any changes. So you have to get used to that if you want to become an astronomer. That is another talk. Why there is red spot, why there are bands, and why do they discover? If I start talking about it, I will not complete my talk. So after the talk, we shall discuss. Yeah? I will remember. So you got the idea? Get used to the object. Study the object well, and then you will know you are doing astronomy or just looking. There's a difference. So observe. This is the thing. Even in your school and colleges, if they give you telescope, just don't take a peek and come back. Stay for a while at eyepiece. Spend few minutes and get used to all the things. Write down what you're looking at it. Writing down is very important thing. Just don't look at it. Take a log and then come out. When we talk about Jupiter, we cannot miss out Mr. Galileo and his contribution to the science. What did Galileo do is something which we all know. We looked at objects with telescope the first time and he discovered the 4 moons and other things else. That is Galilean moons. Even with binoculars you can see. With your telescope you can see it more clearly and you can also measure it, how it moves around. That's the advantage of having a telescope. But since you want to become what? You really want to get rid of me now. Okay. So, okay. You are now want to do something. I will show you what Galileo saw and how difficult it was for him and how difficult a challenge for us also to if you want to take it up. So look at it. So these are 4 dots you saw, isn't it? So where is it? Okay, start moving. What is happening? How it is changing? If you are looking at a plane, how do you know it is actually revolving? It's actually, Jupiter may be oscillating. These may be some rocks in the sky which is going here and there, isn't it? How do you know that these are actually rotating Jupiter?
Sir, see, if you observe a particular moon, so like if you focus on one moon.
How do you know this is, if you see this, tomorrow it will be somewhere here? Okay. But how do you know this is the moon to follow? First of all, you don't know that is moon. Galileo didn't know it was a moon because in this time there was nothing. So how do you know? This is what you should start thinking about, how Galileo did it. In Wikipedia, you will read that Galileo discovered the moons. But how actually difficult it is and how much thinking that goes behind it, looking at it, you can make out. It appears that there are 4 objects just randomly moving in the sky. You don't know whether Jupiter is moving or the 4 rocks are moving or both are moving together.
Sir, if there are 4 different rocks, they always only around Jupiter. So their moons are always around Jupiter.
That's what you have to think about. What happens if they were just rocks? If you are already assuming that they are moons because you have already read about moon. Mr. Galileo never had that luxury. He had to figure it out without. I will give you a thing. You have a telescope, take it out, for your luck, Jupiter is very high in the sky, evening sky. Start looking at the moons without any apps or any software. Start following one of the moons for a couple of hours. Then come back next day and see what happens. Okay. Without, that's why I removed the names. There is no names here. Galileo had to find out which is bigger, which is smaller, and with a small 1-inch telescope, it was impossible. So there was not brightness difference, but he did it. If you do this and come to the conclusion of moons, then you are paying respect to Galileo. Not remembering his name, not just knowing his name. Because you want to become astronomers, think like astronomers, do it and come back with the results. So I am sure it is very frustrating. It will not happen in 1 or 2 months. It will take time, but that's what keeps you occupied, and you will learn a lot about orbits, learn a lot about magnitude, and more thing you kids should learn is patience. You'll learn a lot of it. Already somebody doesn't have a patience. Joking. Tell.
How do we know which moon to follow?
I will not tell you those things. Galileo never knew it. No, you have to randomly see one day and start following it. Nobody said Galileo, Mr. Galileo, here is Io, start following Io. Okay? You have to figure it on your own. There is no names, and when you look at Jupiter, first few days, don't worry, enjoy the surface of Jupiter, but eventually,
With our telescope, can you see like this or that?
this is little difficult. You need a bigger telescope. This is Hubble Space Telescope. So with your telescope, this better than this. This is a very badly imaged thing, but even better. You will not have the glare. You will see distinct bands. You will see a red spot. You will see all those things, so which Mr. Galileo didn't see. So you're going to see with your telescope advantage of these things, and also following all these objects. Okay. So astronomy, you're going to do it, I hope, but takes lot of time. You may pass out, but if you pass out and you don't have access to telescope, come to ABAA, come to planetarium. We will give you the telescope. You can continue the footsteps of Mr. Galileo.
Sir, is this photo taken in the optical spectrum, or is it taken in infrared?
So this is extremely advanced thing. It's called simulation. It's animation. Okay. So it's an animation so that you can get it. Actually, these are all animation 1 day apart. Okay.
Sir, did Galileo see it in this size?
Oh no, even smaller.
Like Jupiter was at the size of those moons.
No, even smaller. It is almost, take a piece of, when you see through a binocular, that is even better than what Mr. Galileo saw. So it was very difficult times, and he had a very narrow field of view, and he had never had any motorized telescope. It was simple small telescope. With that he did science. Now don't tell me with 4-inch of telescope I cannot do anything or see it. You can do a lot of things. Okay. Science doesn't require too much. Okay. Next. You can see this with your telescope, not with all the grandeur, but what is happening? What is this? So who said that? So far away. So I am seeing astronomers, budding astronomers already here. So this is the shadow of Europa, but where is Europa? Here. Io is here, Callisto is here. So what could be, what is causing it?
Sir, because the light has to travel.
That is one thing. Almost you are close. Ah. That is true, but you are close, but you are far. You almost came close. So next slide, I will show you. But you have to measure. You can see it with your telescope. So see through it. Now also it will be like this only. See, you are correct, and this is also correct. What is happening is this. Earth is here, sun is here. So it's the angle of light coming in is different. So you can see it in the, what happens when it Earth keeps moving away, the shadows will keep distancing itself, and when Jupiter and Earth aligns, there will be no shadow. Shadow will be just below Callisto, and then it will start moving the other way around. So the shadow will come this way. So you have to observe the shadow moving across Jupiter over 1 year, and you can measure the distance between these two and also measure the angle, and you will learn a lot about orbits and Kepler laws. All these things come by observing and studying.
Then how will we know which moon's shadow is which?
Okay. Now you can use apps. I will give you maps. So for this you can use it. You can do that. But for the previous, no apps will help you. You have to do it on your own. Okay. This is the orbit, and this happens with Jupiter and also Saturn. You can see it with your telescope, but spectacular you will be with Jupiter. One more thing you can observe and study about is do astronomy. Is follow Mr. Romer. What did he do? You will learn about it and you will talk about it, and everybody loves to talk about it. What he was doing is same thing what you are going to do in the next couple of months. Study Jupiter and study the shadows and eclipses that happens. So he started studying the eclipses that happens, and he found one thing is that there is the eclipse prediction was lagging or happening faster. So this is what you are going to do it. If you start now when it's farthest in June and continue till it comes back in January, there is distance difference, you can make it out, isn't it? There is distance difference, you can make it out. This is what he didn't know. This is what distance. He knew that his calculation was wrong. The eclipse calculation of the moon's shadow casting was wrong. So there is something going on. What it led to is that he was the first person to say that light doesn't travel at infinite speed. It has a finite speed. So when you want to study light speed and everything, which you want to do it in physics, this by observing shadows of Jupiter's moons, you can tell that light has a finite speed just by studying the eclipses. So you have to do this thing for almost a year because you want to become? Okay. Just by narrow, you missed, otherwise another 2 hours. Okay. So light takes from moon to earth, how long it takes? 1 second. From sun to earth? No. So isn't it? So light has a finite. Earlier people thought it was universal and it is infinite. Everything was eliminated at once. But Warner once and for all said it has a limit, and then later it comes to Einstein, later it comes to all of us to study all the other things. But it was him who proved it. And with your telescope, you want to observe the eclipses of the moons themselves. So these are the eclipses of Jupiter moons. So Io eclipsing Callisto, Callisto eclipsing Europa. All these things you're going to see through it. You're going to study it. You're going to study the brightness of it. So what is the brightness study leads to? I will tell you in a couple of slides. Okay? This is not important. You will come to it later. So you have to see it. Again, in the evening sky, it is fantastic. You can see it and enjoy it. It's next to Venus now. So when the sky is clear, take your telescope. With your telescope, you can see all the beautiful rings and the gaps, everything. You can see it, enjoy it. But now if you go and see it, it's like this. It is slowly coming to edge on. That means orbit is aligning, and you will not be able to see the Cassini division. These are all Cassini division. There is one more division here. All the brightness differences, all these, you will not see this, but all the brightness difference of the rings, all this beautiful thing is visible with your telescope. You can measure it, you can enjoy it. But now you cannot see this because if it's edge on. In March, what will happen? It will just line up like this, and the rings will disappear. Why? Every 13 to 14 years it happens because of alignment of orbital plane of Earth and Saturn. I will not explain all those things. It will take you time, go home and read about it. But what you want to observe as an astronomer is that not just looking, and you have to ask why this is happening and what is the reason behind it. So that's what astronomers do. Go out and measure it and write down what you saw today, what was the angle according to you. Slowly see that it becomes thinner and thinner and thinner. In March you will not see it. Then you're going to see the eclipses again, rings again. These two will not change. This is to photo just to tease you. The color difference you can make out, but not anything else. It will appear as small dots in the sky. So we will not spend much time on this. The next astronomy thing, what we are going to do. This is first of all, you want to be astronomer, you have to know the constellations, all the things. Tomorrow there is a very interesting event. No, sorry, tonight there is an interesting event. So this is a constellation, Auriga, Chariot. So you see this star here. So that is called Alnath. So tonight, if you are here, ask Bharat sir to bring his telescope or through binoculars, you see it. That star will be covered by moon today. At what? 8:42, this star will be covered. And at 9:53, 10 o'clock, the star will come out here. What is happening? What do we call this process? Occultation. That means one bigger thing is obstructing the smaller thing, or one thing is obstructing the other. So occultation. Why astronomy occultation is very important, and you are going to see this a lot, and you need to study all these things, because occultations will tell you a lot about the shape. And now also students and public are studying this and giving a lot of inputs to professional astronomers. Still they are trying to find out shapes of lot of asteroids, lot of galaxies, all these things, moons will happen because of coordinated effort by all the astronomers around the world. And why this line differs, you think about it. They are studying occultation to make the size and composition of all the other things. With your telescope, you can do this. This is astronomy. Looking is one thing. Now you want to be astronomer, you have to give away all the glamour and do lot of homework. So this, I'll give you an example. This is a binary asteroid, okay. Asteroids also appear as small dots in the sky, even with bigger telescope. It doesn't have any shapes. But through occultation and through people like you who helped astronomers doing occultation, they could actually see the shapes. You can see the shadow cast, isn't it? The star went here, it disappeared at one time, it came out here, but here it was earlier. So doing occultations and studying occultation, astronomers could find out the shape of the objects which was not visible and could be not recognized with all the bigger telescopes they have in Chile and in Hawaii. But with occultations and simple telescope like yours and mine, we can actually determine what is the shape of the object. But it requires a lot of coordinated effort, and it builds an astronomy community, and you are becoming the part of what community? Okay. The sound makes sure that I have only few slides left. Okay. Okay. So these astronomers, okay, from NASA are studying something very big, so which you are going to do it again. So forget about the size of telescope. They are going to do the same thing. You are going to do the same thing. They are going to take the same readings. You are going to take the same reading. What they are doing is they are sitting in a plane and following an occultation. That means what they are doing, sitting in a plane, and they are actually following transit of occultation of Pluto. That means like eclipse. They follow the eclipse path. They are seeing it. There is a star. And why it is important? Here, you can atmosphere of Pluto, size of Pluto, all these things can be done with occultation. And scientists still think that it is a very important thing, and they are doing it. And with your telescope, you can do the same things. You can study and contribute to science. And once you start doing this, you can move on to professional, and you will be continue, and you will have better understanding. This is the plane they went in. There is a telescope here. So you can look through, and they followed Triton, Neptune's moon. They did the same thing, and they measured what? You can see the star going in. But one more thing, apart from the size and shape of the object, they also found out the atmosphere of the Titan, of the moon. With your telescope, can you do it? Yes. You can do all these things, but patience, lot of hard work in observing, developing your skills, taking down notes, doing a lot of homework, you can do all those things. But can you do it with your telescope? Yes, you can do it. We'll come to the last few slides. What is this constellation? Anybody? Yeah, good, good. What is this star then? Red one. Betelgeuse, yes. So, when we were observing couple of years back, suddenly there was a news that it is dimming. Okay, the star. Now, if you show it to anybody, they will say there is no difference. Since you are now becoming what? Astronomers. You can see that it is dimming, isn't it? Isn't it? So it is very big thing in astronomy news. We at association and Bharat sir, we all saw through telescope and we are amazed at how big it was falling in brightness, and astronomers thought it was going to explode, but never, nothing happened. So,
Sir, is it possible that from a giant supergiant it's become like a white dwarf?
oh no,
As it is
oh no, 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 no. There is a lot of other things. I will not explain the process of what is happening. I am explaining what you can do with your telescope and what you should observe. Okay?
Sir, the star that was dimming was Betelgeuse?
Yeah. This is one. See the brightness difference? It's very subtle. And we in astronomy, we call this magnitude, apparent magnitude, and you're going to do this again. So measure the magnitude and mean what is the brightness. So small brightness change was there, just 0.5 magnitude, and astronomer got really scared. So they thought it's going to explode, a lot of things. This is very small difference. If you are not an astronomer, you will not even make out this difference. But this is a small dip in brightness, and it had a very significant impact around the world. Why? I will come to why measuring the brightness is important. What is this galaxy? How do you know it's Andromeda galaxy? There are a lot of elliptical galaxies. Ah, okay. This is Andromeda galaxy, but again, as scientists, you think about why it is. So appearance, the dust lanes, all these things you have to observe. But this kind of things, even it's not visible with telescopes. Okay, don't worry about it. This is a photograph, and this is more sensitive. So even with my telescope, it's not as beautiful as this. But coming to studying the brightness, why it is going to be long back in 1920s here, there was a star that was brightening and dimming. So Hubble, Edwin Hubble, observed it. 3 slides. He is showing to me or showing to me. He is showing the watch. So 3 slides. Okay. Can you see the changes in brightness? This is happening in Andromeda galaxy. It is actual photo taken by Hubble. This is going to, what is the brightness change that is happening? Why it are measuring? It is brighter and dimming, isn't it? But it's very periodic and it has a very specific brightness. It goes and comes down. Astronomers, this is a star inside Andromeda. That I and you cannot see it. Only Hubble can see it, and they have done it. Okay, so it has a exact measurement. We are going to do this. We call this variable stars. It happens a lot of variable stars here, and it is important that you go and study this. And it happens in 31 days. It goes up and comes down and comes down. Why this is important? Why studying just the brightness? What it tells us. So Edwin Hubble was looking at through his telescope and studying all these, and suddenly he found this gives us distance. We can measure distance out of this. We can measure lot of other things. Now I'm going to stick to distance. With this measuring of distance, suddenly he thought Andromeda galaxy is not inside our galaxy. So he said, okay, Andromeda is very far off. There is one galaxy called as Milky Way, and this is far off. Earlier, everything, whatever you see in the sky, people thought it's inside our galaxy. There was no big. So studying the brightness difference, you and I can make sure that we understand that universe is extremely big. So the whatever Big Bang theory, all the theories what we talk about now, cosmology, started with measuring the brightness of the star. So you're going to do that. You're going to do all the brightness, and you have to. Main thing is take notes. You have to measure a lot, and it takes 300 days, 400 days. It keeps on changing. So in the Perseus constellation, you see different kinds of binary stars. Again, you can make out how the exoplanets have been discovered now. All the other planets because using this method. Okay, so this is all can be done with your telescope. This is Cetus, this Omicron Mira. Again, it has a thing. What it all tells us is that age and how stellar evolution works. So I'm going to skip through few so that the other next speaker is waiting. This is what Ursa Major, Saptarishi. So around 1 o'clock in the night you can see this now. So in that you will see this famous Alcor and Mizar with your telescope. It is in Kannada, and we say Arundhati Vasishta. So this is a very famous star. You can observe with your telescope. Measure the double stars. Gemini, there is a double star. All the skies, the whole sky is filled with double stars. Most of the stars in the sky is double, except our sun. These two are casted double. What do you do measuring with your telescope? You measure and find out the orbit of the stars. This is pure astronomy that you are going to do. This is far beyond just looking and enjoying the double stars. It's a lot of astronomy that goes in that astronomers do every day. You are going to do it. So this is Cygnus constellation, another beautiful star. Color is here, the red and blue. So different colors of stars will tell you a lot of things. It tells you the evolution of stars, how they died, how the formation is done. All this can be done by observing the colors of stars. The colors will be even more. This is again M35 with your telescope. All I'm showing is with your star telescope, you can enjoy all these things. When you're observing, you can also make out the colors of different stars because if you had shouted like this, I would have finished long back. So this is M44 beehive cluster. Enjoy these things. What kind of cluster is this? Kind of cluster. This is called a globular cluster. Okay. This is not so bright in your telescopes. You can finish, but even then you measure the colors, the brightness, all the things what you did till now. You have to observe and study all these things to get a better conclusion of what it's made of, how old it is, all these things. So word of caution before I finish. So I have to make you people depressed. So I'm going to finish it. It's a wonderful photo. How many say this is beautiful photo? How beautiful it is? Very beautiful, isn't it? You're going to go out tomorrow, take your telescope outside, and with all the thing, the skies are clear, it's very dark. Through the eyepiece, what you're going to see? This is what you're going to see. So don't expect to see this. Even with Hubble Space Telescope, we cannot see this. This is what we are going to see. Everything in the sky is grey. Don't be alarmed. Don't think that Bharat sir gave you a bad telescope. Everything in the sky is grey. So you won't see any colors for an object like nebula and galaxies.
How did they capture that?
These are photographic. So photographic emulsions are much more sensitive to eye than eye. So they can do that. But with naked eye, yeah, a color correction, and also our eyes are not sensitive to colors in dark. So ask Bharat why. This is a beautiful trifid nebula, amazing, isn't it? But with good telescope, just above you. So this is what 6 inch. So yours is 4 inch, 6 inch. You can see all these bands, but without color. Remember, there will be no color. It will be hazy patch. This is a word of caution. Don't get excited with all these beautiful colors of Hubble. This is going to be like this. But since you want to become final round, you accept this and you are not worried about how beautiful it is. You want to know what science you can do about this. So do this, observe all these things. Lot of catalogs are available. So download this one, Stellarium, on mobile or on photo, do that. And stick to this one. If you want to become a good astronomer, stick to this one. Do not take the telescope without an observing plan. Just go, don't go out and start looking. Make a plan and don't come back without an observing log. Keep that in mind. Thank you. How long did I take? More than 1 hour?
Yes,
Okay.
it's all right.
Yeah. Already you should have done this, and I would have.
We prepared a placard, but then we forgot to write anything on it.
Oh, you should. I thought of making alarm, vibrator. Totally forgot. Hopefully too much. Yesterday, how long I took?
Only 5 minutes above you.
Oh, God. I should be proud of myself. Bharat knows I. Mic ಕೊಟ್ರೆ. Oh. ಏನೋ ಬೈಕ್ ಹೋಗ್ತಾ ಇದ್ದೆ. They have some questions on them. If they have questions, hello. If they ask questions.
Okay, guys.
Does anyone have questions?
Any questions?
She wants yes. Okay.
Sir, what time or what month do you think is the best to observe the sky through the telescope?
Whenever sky is clear. You cannot wait for perfecting, but you have to make use of whatever is available. But normally the season starts used to start around November. If there are no monsoons or cyclones, start from November to March or April. So when summer skies, lot of dust is there and lot of heat, it makes observation difficult. So, but whenever the sky is clear, take the telescope out and observe. Don't wait for perfect.
How will we know, like, when will this object come closest to the Earth? Like, how will we find the object's position?
Two things. One is by measuring and doing lot of astronomy, which I spoke for 1 hour now. Okay. Otherwise, we have a lot of, I told you, stellarium and other things, which
Yes.
give you map and also give you how close it is. So you can keep track of it. So there are websites which will tell you, so you can study all those things.
Okay, sir. Sir, so initially, as you showed us that the shadows were forming, and I told that due to the angle from which we are seeing from Earth. So now we have apps, but in old times, how did astronomers map those things or see those subtle differences?
Lot of thinking, lot of experimentation, lot of calculations, lot of going through geometry, trying to understand it. That's what. Go through the Galileo's moons. Then you will actually respect scientists after that. Otherwise, it will be movies you see scientists come to office with all the laptops and everything. What actually they do and what the respect you will give them, and you will become one to scientist or not. Depends on the work you are going to do.
Okay,
It's hard
sir.
work, but it's fun. It's extremely fun. Okay, na?
We'll take the last question.